Welcome to lesson 28, part 1. In part 1 of lesson 28, we're going to factor a fourth degree polynomial, similar to how we did cubic or third degree polynomials back in lesson 27. We just add another root that we've got to find, so it just adds a little bit of complication, but the process is still the same. So this is question type Q69, instructions to factor a fourth degree polynomial. Here's our fourth degree polynomial. It's a fourth degree polynomial. We know that because the highest power of x is 4. And the process for factoring a fourth degree polynomial, like with the cubic in lesson 27, is we need to test to find the first couple of roots or factors, however we're looking at it. And then once we pull those out, then we get down to the quadratic, and the quadratic is easy to solve from there. So to figure out what to start with, that's where we're going to use rational root theorem. And remember, rational root theorem says we identify our leading coefficient as p, which is in this case leading coefficient is 1. The constant term is q, and then we list all the factors of q over all the factors of p. And in the case of this problem, since we were not asked to find all the possible rational roots, we don't necessarily have to chase rational root theorem to the end and eliminate all the possible combinations. All we need to do is get a few to start out with for our testing. So the good thing is the leading coefficient is 1. So if we set this up, our denominator is just going to be plus or minus 1, because that's all the factors of 1. The kind of bad news is that constant term is a 144, which has a whole bunch of factors. We only need to identify the first few. So in the number 144, we know that plus or minus 1 is a factor, as is 2, 3 is a factor, 4 is a factor, so there's a lot here, and then it would just go on from there. This at least gives us something to start out with. We know we're going to having to test 1, 2, 3, and 4. So with that in mind, we get started. We're going to test x equals 1, which is typically the first root that I test, because it's often easy to do. We're testing x equals 1, and remember what that means is we're also testing the factor x minus 1, because the factor x minus 1 leads to the root or x-intercept of x equals 1. And using remainder theorem to test it means we're going to evaluate this function at the root or at the x-intercept and see if we get 0. So 1 is often easy to do. For instance, it's going to reduce every, or it's going to replace every instance of our variable essentially with 1, because 1 to any power is 1. So what I mean by that is f of 1 is 1 to the 4th, which is 1, plus 10 times 1 cubed, which would just be plus 10, and then minus 5 times 1 squared, which is just minus 5. And then minus 150 times 1, which is just minus 150, and then plus 144. And then we see if we get lucky and this equals 0. So 1 plus 10 is going to be 11, minus 5 is 6, minus 150 is negative 144, plus 144, thank goodness, equals 0. So what we determined is that x equals 1, and importantly, x equals 1 is one of our roots, and x minus 1 is one of our factors of this polynomial. Now, the next thing we want to do is, now that we've identified a factor, we want to divide our polynomial by that factor so that we get the cubic in this case. And the cubic is going to be a little easier to work with to find out what the rest of our roots are. Okay, so that means we're going to set up synthetic division. If you don't remember synthetic division, you can look that up on YouTube, or I have my own video on synthetic division in Google Classroom. Let's see, so there's our degree 4 polynomial. We're dividing it by the factor x minus 1. So what goes inside the box is the root, or the value of x that makes that factor equal 0. So we're going to put a 1, and then we'll put the coefficients of our problem. So 1x to the 4th, 10x cubed, negative 5x squared, negative 150x, and then 144. Okay, now we go through the process of the synthetic division. Remember, the very first term, we just bring that down below the line. Change colors here. So we have a 1. 1 times 1 is 1. 10 plus 1 is 11. 11 times 1 is 11. Negative 5 plus 11 is 6. 6 times 1 is 6. Negative 150 plus 6 is negative 144. And negative 144 times 1 is negative 144, which gives us a remainder of 0. Okay, so we knew we'd get a remainder of 0 because we're testing a root or a factor, however we look at it. Importantly, though, we get this result. This is our cubic polynomial. So our cubic polynomial is x cubed plus 11x squared plus 6x minus 144. So we're not down to a quadratic yet. So we remember when we did cubic polynomials, we want to pare this thing down to a quadratic so we can break it up. We're not there yet, so we have to do more testing. Now we're going to test x equals minus 1. And we're going to do that like before where we evaluated in the function. So we're going to say f of negative 1 is equal to negative 1 cubed plus 11 times negative 1 squared plus 6 times negative 1 minus 144. And that is going to equal negative 1 plus 11 minus 6 minus 144. I don't know exactly what that equals because that's 10 minus 6 is 4, so that's, I think, negative 148, but it's definitely not equal to 0. Okay, moving on. Negative 1 didn't work. We're going to test x equals 2, which is associated with the factor x minus 2. Okay, so we're going to say f of 2 is equal to 2 cubed plus 11 times 2 squared plus 6 times 2 minus 144. Now we're putting this in the cubic polynomial. That's our cubic up there. And we get 8. Let's see, 8 plus 44 is 52 plus 12 is 64 minus 144. I don't know exactly what that is, but we know it's not equal to 0. Okay, so looks like this one's fighting us a little bit. So we want to test x equals negative 2. So f of negative 2 is equal to negative 2 cubed plus 11 times negative 2 squared plus 6 times negative 2 minus 144 is equal to negative 2 cubed is negative 8. That's plus 11 times negative 2 squared. Negative 2 squared is 4 times 11 is 44. This is minus 12 minus 144. Okay, let's see, so I don't think this equals 0 at all. So negative 8 plus 44 is 36, minus 12 is 24. Okay, minus 144 is definitely not going to equal 0. Okay, so no luck yet. So this isn't 1, this isn't 1. Let's test x equals 3. So we'll say f of 3 is equal to 3 cubed plus 11 times 3 squared. Let's see, plus 6 times 3 minus 144 is equal to 3 cubed is 27 plus 11 plus the 3 squared, which is 9, is 99 plus 18 minus 144. Okay, 27 plus 9 is 126 plus 18 is 134. 144 minus 144. Oh, yay, that equals 0. Okay, good. We finally hit one here. That means that x equals 3 is one of our roots, and therefore x minus 3 has to be one of our factors. And so we want to keep track of the factors we found so far. We've now found x minus 3 is one of our factors, and up here we found that x minus 1 is one of our factors. So we have two factors. Now that we found the second root, we can reduce this cubic to a quadratic. So we're going to do that by dividing it by the factor x minus 3, which means what goes inside the little box here is a 3. Okay, it's the value of x that's going to make that factor equal 0. It's the root. Our coefficients are 1x cubed, 11x squared, 6x, and then minus 144. Complete the synthetic division, we drop the 1, and then 1 times 3 is 3. 11 times 3 is 14. 14 times 3 is 42. 42 plus 6 is 48. 48 times 3 is 144. And negative 144 plus 144 is 0. Good, we have no remainder. And importantly, we know that our quadratic now is x squared plus 14x plus 48. Okay, so by getting down to the quadratic, now we don't have to do the testing anymore. Now we can find our remaining two factors simply by factoring the quadratic. So this quadratic actually factors into two numbers that multiply to give 48 and add to give 14 are positive 6 and positive 8. So this becomes x plus 6 and x plus 8. And now we found our factors. Now we want to piece it all together. The factored form of that quartile is f of x is equal to, okay, remember the first factor we found way up here when we tested x equals 1 and we got 0 is x minus 1. So I'm going to scroll down and say x minus 1. And then the next factor we found after a lot of painful testing was x minus 3. And then the last two factors we got from our quadratic would be x plus 6 and x plus 8. So 4 factors in a degree 4 polynomial. So try the practice quiz 28 and any of the practice quizzes in Delta Math. Let me know if you have any questions, and I will talk to you soon. Bye, guys.